Hello and welcome to the first video in this new series. In this series, we'll be looking at GCSE Engineering and Design Technology theory. In this video, what we're going to be doing is looking at some engineering maths focused at GCSE level. So we're going to be looking at areas and volumes of shapes. What I recommend you do is pause the video as we go along to take notes because you're going to want those later. And as we go through the video, there will be questions related to these topics. So I recommend that you pause as we go along the way and do those questions as we get to them. This will help with your understanding. All right, let's do this. So the first thing we're going to do is have a look at what these terms mean. So we've got area and volumes. So area is a 2D measurement. So this is like saying how many squares of something can fit into a shape. So the way we measure these is usually in millimeters squared in engineering, or it could be centimeters squared, meter squared, kilometer squared, etc. If you were measuring something like the area of Berlin, then you would probably use kilometers. And if you were doing something smaller, then you'd probably use one of these other ones. So what we can then do is take the area of something, and then we can turn it into a volume, which is what we'll be doing in this video. So a volume is the three-dimensional measurement. So how many cubes of something can fit into a box like this? So if you look at the units down here, what we've got is cubic millimeters or millimeters cubed, cubic centimeters or centimeters cubed, cubic meters and cubic kilometers. So on the areas, there was a little 2 here. So it was millimeters squared. In this case, we're looking at cubes. So it's millimeters cubed. Okay. And you can use this to work out all sorts of things like how much liquid could fit into here or how much bacon you can get from a Minecraft pig. I don't know. So let's start with the easiest one. The easiest one to do are cubes. So to work out the area of a shape, we'll be coming back to this a lot as we go along, but the area of a shape is used to calculate the volume afterwards. Now, in this case, it's base times height. So the area of the face of a cube or a square or a rectangle is base times height. Okay. And then volume is area. So if area of this face here, then we multiply it by the depth. Let's have a look at an example, and it should make more sense. So if this was 10 by 10 by 10, then what we would do is multiply this 10 by this 10 to work out the area of the face, and then multiply it by 10 to get the volume. So in this case, the area is 10 times 10, which is 100. Okay, so that's the area of this face. There are 100 square millimeters that can fit into this face. And then to get the volume, all we do is we multiply it by the depth. We'll do that in a minute. So here's a visualization of what we've just talked about. So you've got 10 squares this way and 10 squares that way. Well, 10 times 10 equals 100. All right, let's move on. So the volume is, as we said, the area times the depth. So if you take 100, multiply it by 10, then you get 1,000. So effectively, what's going on here is there are 100 square millimeters in the face, and 10 of those layers could fit here to make 1,000. Okay, so that is 1,000 millimeters cubed. All right, so here's another example. Let's have a look at this one. So we've got, again, the volume is the area multiplied by the depth. So what we would always do first is calculate the area of the face and then multiply it by the depth. Okay, now in this situation, the measurements are all the same. So we've got 30 by 30 by 30. So to work out the area, we would multiply 30 by 30. And then to get the volume, we would then multiply that by the depth, which in this case is 30. So the volume of this cube is 27,000 millimeters cubed. Okay. And what this is exactly the same as saying is 30 cubed. So whenever you see in maths a number that is cubed, this is exactly what we're doing with that number. We're taking that number and we're saying, right, imagine it was a cube of that size. And that's what you get out the end of it. Okay, so if you see, for example, 3 cubed is 27 because it's 3 by 3 by 3. And if you count these cubes, you could work out there are 27 in this cube. All right, let's move on. So cuboids. So this time the measurements aren't the same, they are different, but the process is exactly the same. So what we'd do is we would work out the area of the face, which I've labeled A, and then multiply by the depth, in this case 30. Now, it doesn't matter which one you start with. You could work out the area of this one and multiply by this depth. But for ease, the example here, we're going to use this one. Okay. So I didn't actually do that. You can do that yourself if you want to. So we would take 50 and multiply it by 30 to get the area of the face, and then multiply it by 30 to get the depth. Feel free to pause me and have a go at that if you want to, but I am going to move on to this. Okay, so this is where, when we have exam questions in engineering, this is where people tend to trip up, is because they kind of know how to do it, but do make some mistakes along the way quite often. So what we would do here is we would calculate the volume of the block itself, imagining there is no hole in it, and then we would calculate the volume of the hole and take the one away from the other. Okay, or work out the area of this face here without the hole in it, work out how much is taken up by the hole in the face. Once we get the area of this section here, then multiply that by the depth. That's what I would do. All right, so we still start with the area, and in this case, this is what you get. All right, so if you want to have a go at doing this yourself, start by multiplying 50 by 30 to get the area of this rectangle. Then do 30 multiplied by 10, and crucially, take that number away from the size of the main face you've got here, if that makes sense, and then multiply it by 30, and that's how you get the volume of 36,000 millimeters cubed. Now, we're going to be building on this a bit later on. This is the main area where people trip up, is because people may calculate the block and calculate the hole and then accidentally add them together. Or if there are situations where there's more than one hole, then people forget to take that away or minus it more than once. All right, so we'll have a look at some examples of that in a bit. Right, so parallelograms. These are really easy. Basically, they're exactly the same as a rectangle. So treat them the same. Take the length of the base, take the height, multiply them together. So when you first look at this, it doesn't seem intuitive, but if I show you this, if you imagine that we take this triangle here, we cut it off and stick it on the other side, you can see actually it only occupies the same amount of space as a rectangle. So whatever we gain over here is lost over here. So imagine that just shifts across over to there. So it's exactly the same formula, base times height. All right. Talking of triangles, let's have a look at these. I've put them in a sort of inside a glass box to try and make them easier to see some of the bits later on. So with a triangle, what we do is, to calculate the area, we take the base and we multiply it by the perpendicular height. All right, so not the length of an edge, but the height of the triangle bottom to top. And then divide that by 2. All right, now let's see if we can visualize this a bit better. So if you take this example over here, this first one, you can see here, if we did base times height, the same as we would with a rectangle or a square, you can see the triangle actually only occupies half of that square. So this this equation over here, this base times height divided by 2, you can actually see here is half of that square. So you divide it by 2. Now, with these other ones, the same rule applies. So whether it is a corner-to-corner triangle, whether it's one like this is near enough equilateral, it's not. It's an isosceles, or a scalene like this one here, the same rule applies. And I'm going to show you why. So if you imagine each of these halves of the triangle is its own calculation, you would multiply the base times the height and then divide it by 2 to work out this area. The same over here, base times height to work out, and divide by 2. to work out this area. So if you treat them like two different triangles, you can see each of those is exactly the same as this. All right. And if this was, let's say, 10 across, then it would be 5 times 10 and 5 times 10 divided by 2. So the rule of taking base multiplied by height divided by 2 is exactly the same no matter what type of triangle it is. Okay. All right. So write that down and let's move on. So here's an example. We have got the same formula, base multiplied by height divided by 2. In this situation, I've stuck with 30s again. So we've got 30 wide, 30 tall, and 30 depth. So to work out the area of this face, we would multiply 30 by 30 and divide it by 2. Okay, which comes out as 450 millimeters squared. And I did not change that. Now, to work out the volume, all we do is we take the area of the face and multiply it by 30. Same as we did before. Okay. All right. If you want to have a go at doing that yourself on a calculator, just to make sure I'm not lying to you, then please do. Otherwise, we are going to move on to circles. Now, this is the one where people often go wrong in exams and get confused, is because the formula for this is not quite as straightforward. So what we need to know, first of all, is what a diameter is and what a radius is. Okay, so a diameter is the distance across a circle at its widest point going through the center. Okay, a radius is the distance from that center point to the outer edge. So it's half the diameter. Now, in engineering questions in exams, they may be kind to you and give you radius, or they might be mean and just give you the diameter and expect you to work that out yourself. Okay. And in some of the examples we've got later on, I've got both of these just to make sure that you're paying attention to what you're looking at. All right. Because sometimes reading the question can be as difficult as calculating the answer, and some easy mistakes can get made. Anyway, let's talk about Archimedes of Syracuse. About 2,000 years ago, this guy worked out that if you take the diameter across a circle and you lay that diameter around the outside, around the circumference of a circle, what you get is this situation where you can fit the diameter around 1, 2, 3 and a bit times. Okay. To be precise, it's 3.14159 and so on. Okay. And this number goes on forever and ever and ever. We'll use 3.14 for short. And this number is called pi and is represented by this symbol. Now, this number is really useful for working out all sorts of things about circles and spheres and cylinders and so on. And we'll be using this in the formula for working out the area of the circle in a second. Okay, so here we go. This is the formula. So the area of the face of a circle is calculated by doing this equation here. So pi multiplied by radius squared, sometimes shortened as just pi r squared. Okay. Why is that the case? Well, if you want to visualize exactly why pi r squared equals the area of a circle, I'll post a link in the description below so you can go and have a look at a video that would be better than one of mine that will go through exactly why that is the case. All right. And I think it's worth doing because it shows you exactly why that formula makes sense. And it's really useful to see. All right. So let's do an example. Here's an example. I shouldn't give you the answer straight away. I probably should have got you to have a go yourself. So this circle here, we've got a radius of 12 and a diameter of 24. And like I said, sometimes you'll just get the diameter and you'll need to divide it by 2 to get the radius. And this is what we do with it. So pi r squared, pi multiplied by radius squared. So pi, 3.14, multiplied by, and as we know, when you square something, you multiply it by itself. So 12 and 12, okay? So 12 times 12 multiplied by 3.14, which gives us an area for this circle of 452.16 millimeters. That should be squared. That's wrong. Oops. We'll just cover that over with my mouse, okay? So 452.16 millimeters squared, okay? Right. So let's work out the volume. So all we've got to do with the volume, and I'm hoping by now this is obvious to you, is we just multiply the area by the thickness or the depth. So we take that 452.16 and multiply it by 20 to get the volume. And be careful when you give an answer to have the right units, okay? Very often in exam questions, you get marks for putting the right unit. On my previous example, I got the wrong unit, but thankfully, this one is correct, all right? So we take the area, pi r squared, and we multiply it by the depth, all right? And you can see there, that was my area from the previous slide with the wrong unit. Oops. Rightio. So, half circles and quarter circles, or half cylinders and quarter cylinders. This one is really easy. All you've got to do is work out. So I'm only looking at the areas here. I'm not doing the volumes. To work out the area of the face of a semicircle, all you've got to do is do the equation pi r squared to work out the area of that face and just divide it by 2. All right, we're only interested in half of this circle, so we just divide it by 2 to get half of it. Same with this one. All I've done is done pi r squared again and divided it by 4. All right. So that is really easy. You just calculate it like it's a full circle and then ask yourself, what chunk of that do I actually want? Am I interested in half of it, or am I interested in a quarter of it? If it was a very, very thin sliver, then you would multiply by 0.1 or something, rather than dividing by a number. But we won't go into that here. Right, let's move on. So, in an exam, you probably wouldn't have questions like the ones we've just looked at. Chances are, in a GCSE level engineering exam, you would be asked to calculate the area of some sort of complicated shape or complex shape that's got multiple elements to it. So if you look at this one, all this is really is 3 shapes stuck together. All right, so we've got a rectangle, we've got a triangle, and we've got a semicircle. So what you would be expected to do in an exam situation is to be able to take that shape, break it up in your mind or draw on it into the simple shapes, and then work out, right, what do I do with these to get the area? Okay, so this triangle, easy, is base multiplied by height divided by 2. The rectangle is just base multiplied by height, and the semicircle is pi r squared divided by 2 because it's only half the circle, and that's how we get that piece there. And then all you do is add those together. So let's have a look at this example here. What I would like you to have a go at doing is pause the video now and see if you can calculate the area of this shape. All right. So I'm just going to pause a second to let you pause to have a go at this, and then we'll have a look at the answer. Right. Let's have a look. So the answer to this is 4,327.43 millimeters squared. If you've got the same number or very close, it may not be quite the same depending on your rounding, then well done. If not, then just check your process. So what we'll do is we'll have a look at this. This is 10 wide and 30 tall. So your formula for the triangle should be 10 multiplied by 30 divided by 2. All right. The rectangle should be 45 multiplied by 30. And the semicircle should be pi times 15 squared divided by 2. Okay, so if your number doesn't match this, go back and have a look, and hopefully you'll be able to spot where you went wrong. Hopefully it wasn't me. Right, so what we'll do is we'll end this video just by giving a summary of the formulas involved and the things we've looked at. So for cuboids and for parallelograms, or rectangles, squares, and parallelograms, the area is calculated by doing base times height. For triangles, it's base times height divided by 2. And for circles, it's pi r squared. All right, so pi multiplied by radius squared. And we can use 3.14 for this. I don't think you're ever going to get marked down in an exam by rounding pi to 3.14. Or if you're a really bad engineer, you can round it to 3, but don't do that. And to work out a half circle or a quarter circle, you just divide by 2 or divide by 4. All right. So that is it for this first video. In the next one, we'll be looking at some more sort of exam style questions with the formulas and the answers. It should be a bit shorter than this one, actually. How long is this one? Can't see. But anyway, that's it for the first one. If you've liked this or if you have got anything from it, then please feel free to leave a like. I would be very grateful. Thank you very much.